Okay, so good afternoon, and let us start this last part of this lesson chapter. This would be also in the exam, but tomorrow I might be able to give you time to practice, and on Friday as well. But I will have to start to the next chapter, even though the next chapter will not be included in this exam. It will be included in the next exam. But if I want to wait for you to practice all those sessions, then we will not be able to finish the things that we have to cover. Okay, so I will teach. This is very simple lesson, and I keep it short. And then you can start working for the exam on next Tuesday. And if you have questions, please let me know. Okay, so far we have learned about equations in which I call them linear equations. This means that the power of the unknown is 1. Okay, but of course, later we will learn what happens if the power is not 1, more than 1. Today we want to talk a little bit about those. Very simple version of those equations, not completely those. For example, this is a very simple motivating question. If I ask you, I have a square, I give you the area to be 48, let me make the number simple first. So I give you the area is 64 centimeters squared. Then I ask you, what do you think the size of the square is? What is the length of each side of the square? Okay, you might say that, okay, I don't know the side, so I call it x, but I know the formula for the area of the square. If I have this as x, then the area would be what? X squared. Because if I want to calculate the area of a square, I have to multiply these two. But if this is a square, if this is x, this is also x, and if I multiply them, it becomes x squared, and the answer should become 64, and then I have to find x. And then it is clear that I have to take the square root from both sides. Yes, and then x becomes what? 8. It's a little bit motivating problem here. But algebraically, it's not completely correct, because I am missing something. This equation that I am talking about is not a linear equation, even though it's a very simple equation, but it is not linear. Because if you look at this equation, x squared equals to 64, if I ask you what is the highest power of the unknown that appears in this equation, you definitely will say 2, yes? So this means that this is not linear, because in linear equations the power should be at most 1. This is something we later call quadratic equation. It means that the highest degree is 2. Okay? But now, forget about this problem, and I ask you now, how should I solve this problem? If you answer 8, this is not the whole story, yes? Because when I ask you to solve an equation, I do not mean just give me a number which works. I ask you to give me all possible numbers that work. Okay? Of course, 8 is one of them, but hopefully, if you remember from the lessons that we talked about, square roots and things like that, there is another number here that works, and that is negative 8. So if I ask you to solve this equation, if you follow this is not 100% right. What you need to do, you need to write x is equal to, you put the square root of 64, but you know that there are two answers here. This plus and minus, you have to apply it yourself. Again, I ask you, I have seen even some teachers make this mistake, that square roots of 64, some people write plus and minus 8. That is wrong. If you take your calculator and punch square root of 64 100 times, even once you will not get negative 8. All the time you will get positive 8. So square root of 64 is always 8, not plus or minus 8. The plus minus comes before that. Here, if I ask you, what is a square root of 64? You definitely, without any doubts, tell me it is 8. But if I ask you how many numbers are there, so that when I raise them to power 2, it becomes 64, then you will give me two answers. One of them is 8, the other one is minus 8. One of them is a square root of 64, the other one is negative square root of 64. So plus and minus is not coming from square root, is you put it by hand before writing even the square root sign. So if I ask you then what is this one, you will tell me this 8, but before that I have applied plus and minus. I really want you to understand there is a big difference between the square root of 64 and find the answer to this equation. Square root of 64 is not two numbers, it's one number, and that is always 8. But this doesn't ask you a square root of 64. It is asking you for all numbers whose second power is 64. One of them is the square root of 64. There is another one, and that is minus the square root of 64. So this is why you get plus and minus 8. Yes, is that understandable? So never write square root of 64 to be plus and minus. Okay, so this is the answer to this one. Of course, in this problem, because I am solving a geometry problem, the negative answer doesn't make sense. So if I am solving algebra, you have to write plus and minus 8. If you write one of them, not the other one, it's not complete. But on the other hand, this is completely in the other direction. If you are solving this geometry problem, you know that x is the name of the length of this square, and it is nonsense to say that the length is negative 8. So from algebra points of view, there are two answers, but if you are solving this geometry problem, one of them is not acceptable in this context, the other one is acceptable. Is that understandable? So this is more or less the whole story. So let me give you another example. If I give you x squared is equal to, for example, 15, and I ask you to solve this, I am asking for all numbers so that after I raise them to power 2, it becomes 15. So what are they? And I ask you to answer exactly. Approximately, you can take your calculator, put it in the calculator and calculate approximately. But if I ask you to solve it, full stop, you have to give me the exact answers. So what are the exact answers?
Plus minus square root of 15.
End of the story, yes. X is equal to plus or minus square root of 15. By the way, plus and minus way of writing is a lazy way of writing what? X equals to, this means, by the way, be careful, even if you are lazy, this is ubiquitous in mathematics, people write like this, but what do they mean? They mean x is equal to square root of 15, x is equal to minus the square root of 15. I need to fill up this blank. What is that blank?
And?
No.
Or.
And cannot happen. Or. It has to be or, because x cannot be this and that simultaneously. So this is a compact version of this expression that x is either square root of 15 or x is equal to minus the square root of 15. So whenever you see this symbol, this notation used in mathematics context, this means this. Okay, but now let me ask this question. But instead of having the second power, that is the topic today, power equations. So there is no guarantee that the power is 2, but let me change the power to 3 and I ask you the same question. Okay, then what is the answer to this? First of all, how many numbers do you think there are? So let me start with a better number. So let me start with 27. Okay, if I ask you, solve this equation, how do you solve this? I am asking you for one x, or no, I'm asking for all possible x's so that after being raised to power 3 it becomes 27. How many numbers do you think there are? Yes? 1. What is that?
3.
And that is 3. There is no plus or minus in this case. So the only way that I want to write it, if you want to write it really officially, what should I write? I will write the third root of 27. Do you remember? If you have forgotten, you can review some of those videos. So x is, now the third root of 27 is 3. And that is the only one. So let me just make this important distinction. So there is a difference between an even power and an odd power. in the case of even, if you want to find all possibles, you have to put plus and minus because there are two options. If the plus one works, definitely the negative one also works, yes? Because if I have a negative number raised to an even number, that even number will actually terminates this negative sign. So if you have an even power, be careful that you have two answers. And if you have an odd number, you have one answer. Yes? This is one thing. Another thing is that if you have an even power, let me put here minus 16. And if I have an odd power, let me put here minus 27. So what would be the answer to this equation? What would be the answer to that equation? Let us think about this. Can you guess or can you find a number so that when it is raised to power 2 it becomes negative 16?
No.
No. So this doesn't mean that this is wrong. If this is given in the exam, you should write no solutions. Why is that? Because we learned before that if I have any number, even if the number itself is negative, when I raise it to power 2, which is even, it becomes positive. So it is not possible for have negative 16 out of it. So no solutions. But what about the other one? Are there still solutions? Yes?
It's minus 3.
It's minus 3. Yes? Okay, now let me ask you this question. What happens, do you think there is any case that I have power of 2 but I get only one answer instead of 2? Because you see, I told you that whenever it is possible to get an answer, don't forget to put this plus and minus. So you might think that all the time I will generate 2. Yes, most of the time you generate 2 except one special case, yes? What? 0. It is 0, yes. If x squared is equal to 0, of course, again, if you want to, you can write is x is equal to plus or minus square root of 0. But the square root of 0 is 0 and there is no difference, plus 0 and minus 0, we can simply write 0. So that is the reason, that's an exception. So you don't need to go through this step. Whenever you see this, the only answer is 0. So this is that exception. Otherwise, when I have an even power, I have to always care about this plus and minus sign. So let me ask you one other question. X to the power of 6 is, for example, 79. I want to answer this question. So what's the answer? X is what?
X is plus minus.
Plus minus?
Square root of 7.
6th root of 79.
6th root.
9. Yes? And that's it. But by the way, there is no sign like this in your calculator. We have already discussed about that. If you want to find approximate value for this, you will not have this button on the calculator. You have, this is definitely you have. Some calculators also have this separately, but not more than 3. But now assume that you want to calculate this using your calculator. Yes, Tim? Oh, really?
Yeah, this fails.
Can I see that? So you have a button with some unknown on top?
Yes.
Okay, I understand. Yes. Okay, but many calculators doesn't have. But it doesn't mean that you cannot use those calculators to calculate this. The reason that I brought this up, because I want to remind you about a formula we studied before. Whenever you're talking about powers and things like that. So do you remember what that formula is? So this is extremely important to remember. The nth root of a is what? Is a to the power of?
1 over n.
1 over n. This is extremely important. If you have forgotten, review this again and write it down again to remind yourself. So if you want to calculate this, if your calculator is capable of doing this, as Tim said, you can just use that button. But if that is not the case, you need to change it to the power notation, 79 to the power of 1 over 6. And then definitely your calculator is capable of calculating powers. And then you use that power button to calculate this. Okay, any questions so far? We cannot actually increase the level of difficulty here that much, because as soon as I want to make it difficult, I need to go to Math 2C then. But let us make it more interesting problem. Do you think we can also solve this problem? So if I give you 5x to the power of 4 is equal to 20, and I ask you to find x. So you see this is not a linear equation because the highest power is 4. The linear equation is just 1. But if I want to solve it, what is the first step to do? If the 5 was not there, the step was to write plus or minus the fourth root of 20. But yes,
You have to divide by
first we divide, because we say that this is your black box, you don't know it, because you don't know x, but you know that 5 times of this box is 20. So it is clear that the box itself is how much? 20 divided by 5, which is 4. And then you have this problem. Because this is even, it becomes plus or minus the fourth root of 4. And that is your answer. And just let me remind you, of course, in this exam, if you write this, that's acceptable, but you can simplify it a little bit more. Do you remember? The fourth root of 4. Can I simplify it? I can write it as the fourth root. Instead of 4, I write 2 to the power of 2. But if you remember, we were able to simplify this power with that number up there. So then it becomes the second root of 2 to power 1. But no one writes 1 as a power. No one writes 2 as the square. So we just simply write square root of 2. So the fourth root of 4 has a better name for us. And that is the square root of 2. So in that case, if you haven't forgotten that, I would prefer you to write plus or minus square root of 2. So if I want to solve that equation, my answers are plus and minus square root of 2. Okay, so what about this equation, for example? Can we solve this equation? For example, 3 minus 2x to the power of 5 is equal to 27. So how should I solve this equation? Is this a linear equation? No, that is actually a fifth degree equation, because if I multiply this by itself 5 times, then the highest power of x which will appear will be 5. But how can I solve this problem? Yes?
Since but I would start with taking the fifth root
Exactly,
of both
exactly.
sides, because
Yes, exactly. Because you are saying that to yourself, that this is something that I don't know.
Yeah, and
But I know something. I know whatever it is, after being raised to power 5, it's 27. So actually I know it. I shouldn't say that I don't know. So I immediately realize that 3 minus 2x is equal to the fifth root of 27. Yes? Is that understandable? I have a number. I don't know the number. But I know that when I raise it to power 5, the answer is 27. So if I ask you, do you know this number? You would say, yes, the answer is the fifth root of 27. Yes? Yes or no? Yes. But now I am looking for x. Is this equation a linear equation? This is a linear equation because the highest power of x is 1. So how should I solve that? I need to keep the x on the left. I need to move this to the other side. Fifth root of 27 is already there. I move this to the right hand side. It becomes negative 3. I am looking for x, so I have to make x alone, so I divide by minus 2. When I divide by minus 2, I don't know. I can divide this by minus 2 and this by minus 2, or I can write this totally divided by minus 2. It doesn't matter how do you write this one. Because I want to keep it exact, that's my answer. You don't need to simplify it more than that. But I myself prefer to avoid minus signs as much as possible. So what I do, let me ask you, do you understand that this is okay? Yes? What I did, I rescaled this by minus 1. I multiplied the denominator by minus 1, it becomes this. I also multiplied the numerator by minus 1. This minus 3 becomes positive 3. This positive is fifth root becomes negative fifth. So you see that you can also solve a lot of equations even though they are not very, very simple, but you can still solve them. So this is the answer that you provide for this one exactly. And of course, if I ask you what is the approximate value, then you need to put it in the calculator to see how the approximate value is. Yes or no?
Can you describe again how you went from negative to?
Okay, so you see, if I have a number here and b, if I want to, I can write it negative this one, yes? So if I multiply the numerator and the denominator simultaneously by a negative sign, the fraction that I generate is equal to the previous fraction, yes? I did the same thing here. I multiplied a minus sign here, and I also multiplied the minus sign in the numerator. Yes? So what I am telling you is that whatever I have here and whatever I have here, they are equal. Yes? Because I have just... But minus 2 is just 2. And then when I multiply this negative sign, I have to multiply it here, and I have to multiply it there. Multiplied minus by minus 3 becomes positive 3. Minus by this number, which was positive, now it becomes negative. Is that understandable? Okay. Let me ask you this question now. For example, what do you think about this problem? 3x minus 2 to the power of 4 and then minus 10 is equal to, for example, 5. So we want to solve this equation. It means that I am looking for all possible values of x that satisfy this equality. Okay, can you tell me what to do? What is the first step? Yes, Carmen?
I had a question about the other...
Louder, please. Louder.
Oh, I had a question about the other problem. So where, with our answer, if I wrote minus 2, like as the denominator, would that still be valid as a...
Yes. If you stop here, that's valid.
So you would get the full mark?
Yes. Even if you do this like that, I divide by minus 2, x becomes equal to, I can divide this by minus 2, and I can divide this by minus 2, so it becomes positive 3 over 2. Even if you write this, that's also okay. This is also okay. That's also okay. Okay, but what about this problem? What is your suggestion? What is the first step? Yes?
You can add 10.
Exactly, thank you. So you need to make x alone, and it is not hard. You need to think yourself which one has the priority to get rid of. It's easier to move 10 to the right. So then it becomes 3 times x minus 2 to the power of 4. And then I move it to the right, it becomes 5 plus 10. And let me simplify that once. It becomes 15. Okay, what would be the next step now?
Divide both by 3.
Yes, I have to divide by 3. I divide by 3, it becomes 5. What is the next step now? I need to get rid of this power 4, yes? So what should I do? I need to write x minus 2 is
4th root of 5.
4th root of 5. It's not complete.
Plus minus.
Plus minus, why? Because the power involved is even. Yes? And then I want to have my x. So what should I do? I need to move 2 to the other side. So what happens? 2 becomes positive, but either I have plus or I have minus, the fourth root of 5. If I ask you what is the meaning of this symbol, you say that this means the answer that I am looking for. There are two answers. One of them is this strange number, but that's a number. The other one is this number. You don't have to write this, but you have to understand this is the shorthand way of writing this sentence. Be careful. I am very interested in exact numbers. Very seldom I will ask you to find approximate values. Yes? Approximate values are for practical problems. If you want to solve an engineering or a practical problem, then of course yes. If I ask you how much I need to make this table long, if you give me this number is useless. Yes? Because I need to have a feeling of that, yes? If I want to make something, if I want to make a table and I want to have the table with a specific size, if you tell me the size, if the length of this table is this number, that's not that much helpful in practice. If you are a carpenter and you want to make it this number is not that helpful. So because your meter is not capable of measuring that exactly. So that is why we actually use approximate values. But in mathematics we are living in an imaginary world that everything is exact, so why we should give up this luxury to have exact values. So that's very important that in this lesson we will keep the exact values as much as we can. So for example, if you tell me what is pi, this is pi for me. That 3.14, or I don't know, the next one I remember 15, this is not pi, this is just an approximation for pi. Yes? But if you ask me what pi is, what can I say? I can say that if I draw a circle and I measure this and divide it by its diameter, that is pi. I cannot define more than that. If you say that, okay, how much is approximately, then this is approximately, but that is pi. Yes? Okay, so I don't think you have big problems here. Let me also finalize this lesson. The last part of the lesson is that if you have fraction powers, okay, so this you need to make x alone. For example, can you tell me what should I write here? If I give you x to the power of 1/3, so let me clean and make it nice. So here so far you see if I have put something in the power, it was a natural power. By the way, let me ask you this one. What do you think if I have a negative power? How do you solve this equation? And then after that, I will finalize the lesson with fraction powers and then we are done. If I ask you find x, how do you solve this equation? I am asking for a number so that if you raise it to power -4, it becomes 5. The first thing that you need to remind yourself is that what the meaning of negative power is in the first place, yes?
Can you, or does the rule with that something raised to negative power is just 1 over
Yes, yes.
x?
Yeah.
Does that rule also work with roots?
Yes, yes. Yeah.
So we could just...
No, for that roots I don't know, because we do not have this symbol you will not see. Even though it is not strange to define, but this symbol I haven't seen in math literature.
It's
Yes?
not that useful.
Yes.
Okay.
But what you said is correct. You say that x to power -4, do you remember what was the definition?
1 over x.
1 over x to the power of 4 is 5. Okay, do I know this? For the time being, I don't know this. But I know that 1 over that is 5. So I know what this is actually. What is that? A number 1 over that number becomes 5. So the number should be 1 over 5, so that I do it once more, it becomes 5. Yes? Is that understandable or not? I am asking, what can I put in this box so that the answer becomes 5? What that number should be? Yes?
1 over 2.
No?
1 over 5.
1 over 5.
1 over 5.
Be careful. 1 over any 1 over A. What is the answer?
A.
It's A. Yes? So 1 over the question mark is supposed to be 5. So this means that my question mark is 1 over 5. Yes? So now if I ask you 1 over this one is 5, you can understand that x to the power of 4 is what? 1 over 5. Yes? This is 1, and then can I solve the problem?
Kan man göra sådär?
We can solve the problem because this is the normal problem now. X is plus or minus a square root of, no sorry, fourth root of 1 over 5. Is that understandable?
Yes.
So this is one way of solving this problem. Can I write it simpler? The answer is yes. You remember I told you that if I have this formula, you can write it for the numerator, you can write it for the denominator. But this is a famous number. You don't need even your calculator to understand. The fourth root of 1 is
1.
1. That's it. So it becomes plus or minus 1 divided by fourth root of 5. So you see, you were able to answer that. This is one way of solving the problem. Let me solve it another way. X to the power, if you the second way that I want to solve it will be useful for all cases, by the way. If I want to get rid of this, what can I do? For example, x to the power of minus 4 is 5. Then, if this is equal to that one, x to the power of minus 4 to the power of minus 1 is equal to 5 to the power of minus 1. Do you agree with me? If you tell me that these two numbers are equal, then I can conclude that this one to power minus 1 would be the same as this one to power minus 1. Yes? But then what happens? Do you remember what is the rule of a to power m again to power n? It was a to the power of mn. So here I can do what? It becomes x to the power of multiplying these two, which is 4. And 5 to the power of minus 1 is nothing except 1 over 5. So and then you see that I just got this equation back. So that's also one way to do this. So for negative powers, we do not have any problems. The same idea that I told here, work with fraction powers. So if I ask you this, x to the power of 1/5 is equal to negative 2, and I ask you to find x. How do you find that? So you see, in solving equation, there is a very general strategy. You shouldn't be distracted. You say that, okay, I need to remember a lot for this one, I have to do this, for this one, I have to do this. Yes, but there is a general strategy. You have to make x alone. That is the grand strategy behind all those methods that we have developed so far. Yes? I want to make x alone. So how should I do that? Can I move something to the right? No. Can I divide by something to make it alone? No. So I need to think in a way that I should make it alone. So what should I do?
Power of 5.
Power of 5. So if you have this strategy in mind, you really don't need to memorize many things. So I want to get rid of this power, 1 over 5, to make x alone. If you have done your homework nicely so far, then it is not hard for you to realize that I have to raise both sides to power 5. Yes? Why is that useful? Because immediately you can give me the answer to this. The answer to this is x to the power of 1/5 multiplied by 5, which is 1. Of course, we don't write 1 because x to the power of 1 is as x itself, so I reached my goal. X is alone now. And then minus 5 to power 2 is multiplying minus 2 5 times by itself. It becomes negative 32. That's it. So you see that, remember, the general strategy to tackle an equation for the time being is to make your unknown alone. Okay? And then you have to use all math knowledge that you have gained up to that point to make this right. Yes? What about this one? If I tell you that what is the answer to this? Yes?
Minus 16.
No. Be careful.
Plus minus square root.
No.
Wait.
No. No solutions.
Oh.
Be careful.
Oh.
That's what I'm saying. Be careful. If you don't understand what you are doing, you will get an answer for it. Why? Because you raise it to power 4, as we did before. And then you tell me that this is equal to what? X to the power of 1, and minus 2 to power 4 is 16, and you might think that this is the answer. But is this the answer?
No.
This is not the answer. Why? Because the fourth root of 16 is, what is the fourth root of 16?
It's 2.
It's 2. Not minus 2. Yes? So be careful. So you need to understand no solutions. So let me just cross this over. Yes?
Do we get any questions like this that the answer here will be no solution?
Yes, yes. Yes. You need to be careful because that's the whole point. Why this happens? Because I told you some operations are not reversible. Raising to power 4 and going back are not reversible. So if x is equal to y, I can safely conclude that x to the power of 3 is y to the power of 3. And if you give me this, I can also safely conclude that. But for power 4, this is not the case. If they are equal, x to the 4 is equal to y to the 4, but there is no guarantee that I can come back. It might happen that the fourth powers of two numbers are equal without having them being equal. Minus 2 to power 4 is equal to 2 to power 4. Both of them are 16. But they are not equal. Minus 2 is not equal to 2. So you need to be careful. So do you remember I told you that fourth, this symbol means, do you remember we were learning this very good actually. If you have forgotten, you can review some videos. X to the power of 1 over 4 refers to the unique positive number, so that when I raise it to power 4, it becomes x. So it cannot be a negative by that convention. So be careful about that. Yes? Okay, but let me forget about these tricky parts. But if in principle, if I want to solve it, you know what to do. Yes? So let me ask you this question. What do you think will happen if I ask you this equation? X to the power of 3 over 5 is equal to 7. If you want to find x. What is the answer to this x? Again, the strategy is to make x alone. So what we are supposed to do? Yes?
I would start by dividing up the 3 over 5 into x, or the fifth root of x to the power 3.
Yes.
X cubed.
Yes? But do we really need that? We can simply do it. I told you what is the strategy. The strategy is to make x alone. So what I'm supposed to do? Yes? No, but you can say if that's completely wrong, we can correct you. Yes?
And maybe raise it to 5 over 3.
Yes, that's better way. Yes, I would prefer that one as well. So what you say is that you write this and raise both sides to the power of reciprocal. And then it becomes 7 to the power of 5 over 3. First of all, is that understandable? And why this method is useful, as Simon said, is because he chose this number wisely so that when these are being multiplied, they cancel out. Yes, so that's why. And then I hope that you agree with me that this one multiplied by that one is x. What is left for me is that number. Yes?
But how would we avoid falling into the trap of the other problem with x to the power 1 over 4 is equal to negative 2? Because they're...
No, whenever it comes to raising even powers,
yeah,
that you need to be careful.
yeah, exactly. But
This is I intentionally avoided the even powers.
but because I don't know. How is a fraction even?
No, fractions are not even or odd.
Yeah. So then, how do we know that? How do we know if we can do this or how?
I understand your concern, and that is really that's important to understand. But for example, what I'm saying is that you need. That's what I'm saying. You need to understand what these symbols are sitting for, not just blindly do the operations.
Yeah.
And I told you that whenever we learn an operation, we have to learn the limitation of those operations. If you have already done that, you understand that you will not face any problems here, but you will face a problem here. Yes? Because by the way, I am assuming this is true, I am continuing. But this is not possible in the first place to start with. You know, do you understand what I mean? Because here, this is, by the way, this logic is not wrong. This logic tells you that if there is a number with that property, that number is 16. You see, but there's a very big if. If there is a number that with that property, that number has to be 16. But it doesn't guarantee that 16 is the number. Do you feel the logic? Okay, and this if part is wrong. Because there is no number with that property in the first place because of the definition here. Yes? So in principle, if you really want to be careful, yes, you have to be careful all the way around. But when it comes with odd powers, I don't have any problems. Yes?
So,
but if I have this situation, let us try explore. I don't know. I'm just making something because of your question. For example, if you want to answer that one.
Well, that should still work because we don't have any negative numbers that could be problematic.
Yes, but let us see. I don't know myself. Let us see. So that's a good question. So I hope that you understand this one. Let me complete this. If you stop here, that is okay. But do you remember there is another name using the search sign for this? Do you remember? A to power m over n was the nth root of a to power m. So if I want to, I can continue and write it the third root of 7 to power 5. But still I can simplify it a little bit. I can write it as the third root. Instead of 7 to power 5, I write 7 to power 3 times 7 to power 2. But the third root of 7 to power 3 is 7. And 7 to power 2 is 49. So if I want to answer this and impress my teacher, I will write it in that way. Yes? I will not stop here. So I would write it as 7 third root of 49. Of course, that's also the same thing. That's not wrong. But I want you to learn that one. In the exam, if you stop here, that's okay with me. But that's also good to know. But let us go back to this question. By the way, for example, let me answer this question. What is your answer now? For example, if I ask you to solve this, you should understand that there are no solutions. Why is that?
To an even power.
No, because you need to remember what is the meaning of this power in the first place.
Yeah.
If I give you a to power m over n, do you remember how do we define that? We told that this is a to power 1 over n to power m.
Yeah.
Yes? So in that case, this means x to the power of 1 over 5 to power 2 is equal to minus 7, of course I will not carry on.
Yeah,
Because something to power 2 cannot be negative, so no solutions.
yeah.
Now let me solve this one. Let us solve this one.
Well, that would be this, or would be the same thing as you wrote.
Okay, so what do you think? So
X to the power of 1 over 5 to the power of 2.
2, yeah.
And then we move the to the power of 2 to the other side, or we take the square root of 7.
Okay, tell me. A square, what should I write?
Plus minus square root of 7.
This I have to write plus minus the square root of 7. Then I want to make x alone, so what should I do? I need to raise to power 5.
Yeah.
So then what happens? X becomes plus or minus the second root of 7 to power 5.
Yeah.
And then this makes sense. So this becomes, if it is positive to the power of 5, remains positive. If it is negative to the power of odd number 5, remains negative. So it becomes again plus and minus. And then this becomes this second root of 7 to power 5. And if I want to simplify that, how should I do that? I would write it as 7 to power 2, 7 to power 2 times 7. This 7 and that 7 can go out, so 7 times 7 is 49. And then I have a square root of 7. So this is a simple question, but complicated actions, yes? So what I have to do, the answer to this is just this. X is equal to plus or minus 49, the second root of 7. Yes? But now let me ask you something. This method will give you only one answer. This method that Simon told here. So when we are dealing with even numbers, then we have to be careful. Yes? So here, the method that Simon introduced, let us introduce it to this problem. Let us see what happens. So, what should I do now? I have x to the power of 2 over 5, and then I raise it to 5 over 2, as Simon mentioned. So then I will get 5 over 2 here. Then definitely the answer here becomes x, and this becomes 7 to power 5 over 2. Of course, this is not wrong. This is the positive one. But we are losing the negative one. Yes? And the reason is that this is the right way to do it. So whenever you don't know what that it means, you need to start from scratch to see what you have to do. If you just blindly do things, it doesn't work. Yes? So it means that when one of these numbers is even, this is not the whole story. This is one part of the story. Yes? I don't want to confuse you, but that is real mathematics, because I don't know how many of you have seen these videos and people are proving 1 is equal to 2, I don't know, proving 0 is equal to 10, proving infinity is equal to 0. This is why they are tricking you in this way. They are using the ignorance somehow that you are not understanding what you are doing. Apparently you are always doing the same thing, but here you see that it was right more or less, but if I want to understand this problem, I need to ask myself, what is the meaning of this object in the first place? So if I want to ask, exactly like Erasmus asked, and this brought these things, you see, this is defined in this way, and then you immediately realize something to power 2 is 7, so this something are two numbers, plus and minus. You immediately understand. But if you want to blindly do these things, then you will have problems. And that's the whole point. Yes?
But if you write plus and minus 7 to the power of 5 over 2, do you get the full mark on the test?
Don't forget, don't care about the full mark so much. But then I will ask you, how did you understand that? Yes? Because so far we learned that, you see, I will not probably give you those tricky questions, okay? But this is not, by the way, beyond the knowledge of your math right now, because after you ask and I explain, you understand. But the point is that you need to go to that level that you understand this. This is why the people who are actually interested in mathematics, this is my real recommendation. do not follow the rules blindly. Yes? Whenever I write a formula, there is some kind of limitation for the applicability of that formula. It's extremely important. Good students in mathematics know about those limitations. If you don't know, then you will have a lot of problems. Yes? For example, I don't know, might be we can have this formula. Some people have it in mind, but this formula has a limitation. What are the limitations for this formula to be correct? Square root of a dot b is equal to square root of a dot square root of b. Yes?
A and B can't both be negative?
They have to be both positive or zero. They can, none of them can be negative. Yes? So if you don't respect that rule, then you will have problems. Yes? So I don't know, might be you write square root of 1 is equal to square root of minus 1 times minus 1. So this is completely right. You cannot say that you are not allowed to write that, because otherwise mathematics will collapse. Because 1 and minus 1 times minus 1 are the same thing. So this has to be right. But then if I blindly use this formula, this becomes square root of minus 1 times square root of minus 1. On the other hand, square root of 1 is 1. And I don't know, you have seen some numbers. This is the I imaginary number. So people say this I squared. And then they say I squared is equal to 1. But I don't know, if you have a third complex number, I squared has to be minus 1. Then you say that how is that possible? I squared is minus 1, I squared is 1, then it means minus 1 is equal to 1. So you see, this is important to avoid. The reason is that if I want to follow this, this here is correct, this is correct, this is where it is not correct. So you see, you shouldn't use the formulas blindly. You really need to understand when am I allowed to use the formulas. Okay? And that becomes, so you need to be a little bit, you need to be actually more observant whenever you want to learn something. Learn it with everything, not just formulas. Okay? I think we can end the lesson here now, and then I have already written on on Google Classroom what to do, but I haven't published that. I will publish it now. So let me stop this video. So everything we were